Yeah, thanks, Ferenc. Great to be able to give this talk. Yeah, so many of you in the audience have done amazing work to promote CT through programming environments, robotics courses, as well as unplugged activities specifically designed for children and teenagers. However, what constitutes CT is not very well defined, as we have heard. As a result, we critically lack understanding of the cognitive, affective, and motivational mechanisms that influence the learning of CT. But a better understanding really is crucial if we want to make learning to code more enjoyable for all. So I'm part of a project combining methods from psychology and computer science, led by Karin Warndal from the University of Graz and Wolfgang Slani from the Technical University of Graz. And in my work, I focus on the relation between maths and CT. And yeah, I'd like to offer you some insight into my work here. So we've already heard a lot of definitions of CT today. And actually, I was quite happy to find that Eva chose this definition also in her keynote talk. So what I really would like to stress is that CT is really about problem solving. So there's a problem which needs to be solved in a certain way, and Shute and her colleagues, they talk of 6 core CT concepts. So the problem needs to be decomposed into smaller, more manageable parts, and through systematic and iterative debugging, it's possible to come to a good solution with no loose ends, and through abstraction, it's possible to get to a good solution that is generalizable also to various problems that are similar. And finally, algorithm design allows us to get solutions that are reusable in a lot of circumstances that are similar. So let me just, here, now I can see my full screen. That's always a good thing. So we should really ask ourselves, if problem solving is such a central aspect of CT, is CT just simply determined by all problem solving or reasoning skills or general mental ability? Or do other cognitive mechanisms also play a role? And what are the precise cognitive mechanisms involved in CT? So what we know about CT and the related cognitive abilities is arguably still limited, but there has been some work done on the relation between CT and cognitive abilities. And we've already heard a bit about this work in the first symposium. These have been some really important pioneering studies providing first insights, but most of them were really small scale. So we've heard about studies with about 20 participants from 1 or 2 classrooms, which makes it really hard to generalize these findings to the general population of all students. Moreover, some studies looked at special samples, for example, participants of robotics courses, or there are even studies looking at gifted and talented students. So again, this makes it really hard to get conclusions for the general population, even though it's really interesting to look at special samples as well. Lastly, many measures rely on self-reports or indirect measures. For example, by looking at students' math grades, you get a rough and economic estimate of students' mathematical abilities. But math grades also depend on other factors such as motivation or socioeconomic status. So here's a brief summary of what we already know. Most studies really do find that CT is related to individuals' general problem-solving skills or reasoning. And yeah, that's what the overwhelming majority of studies do find. There has been some limited evidence for an involvement of short-term and working memory. We've heard about this before. And also spatial skills seem to play a role for CT. Interestingly, there's only very mixed evidence for an involvement of mathematical skills. So some studies find evidence that math is somehow linked to CT, whereas others don't. Reasons may be because these studies looked at different age groups or used different tasks to measure CT or maths. But let's just step back for a moment and think about why maths may be theoretically linked to CT at all. So let's go to the definition. Schutt and colleagues really stressed the importance of algorithmic problem solving to develop solutions that are applicable not only to one single problem, but rather classes of problems. Here I see substantial overlap with higher order mathematical skills such as algebra. In fact, the term algorithm is derived from the name of the Persian mathematician Al-Khwarizmi, I hope I pronounce it correct, who wrote the famous text Al-Jabr in the 9th century. In this text, the author described sets of rules and techniques to solve any algebraic equation with a certain form. Incidentally, the term algebra is derived from the title Al-Jabr. This work was absolutely groundbreaking, as for the first time, an equation was not only used to solve one certain problem, but instead addressed all problems belonging to a certain class of problems. In other words, algebra also fundamentally relies on algorithmic thinking, and it's something students actually learn in school. It's part of a math curriculum. Now, how can we reconcile the conflicting empirical findings on the relation between CT and maths? A great idea to deal with surprising and conflicting findings is to do a replication study. Replication is important because it helps check the validity of previous knowledge. Thus, we decided to submit a registered report to a special issue in computer science education. We decided to replicate a study by Marcos Roman Gonzalez and colleagues, which actually had a quite decent sample size, but did not find any evidence for a relation between CT and maths. To assess CT, the authors employed their self-developed computational thinking test. We've heard about this test also in previous tasks. The items address different CT practices and concepts. And for instance, in this item, it's necessary to identify a mistake in this code. So how can I get a laser pointer? That's necessary here. Here is a mistake somewhere in one of these steps. Because we're dealing with identification of mistakes, this item is thought to address debugging. And to solve this item, you also need a broad understanding of loops. So the authors looked at a huge sample of over 1,000 students from grades 5 to 8 of Spanish schools, but a smaller subsample completed all subtasks of a mental abilities battery. So they assessed reasoning, verbal skills, spatial skills, as well as numerical skills. Here again is an overview. So 136 students completed measures on these constructs. The authors were also interested in short-term memory, but were only able to assess this with a very small sample, just as a side note. For reasoning, they had also a sequencing task, which reminds me a bit of the number sequence task Irene talked about in the first symposium. So participants were asked to say which letter constitutes the logical continuation of this series. So C, A, D, A, E, A, F, A. Yeah, G is the logical continuation. For verbal skills, there was a test of finding synonyms, like which word has the same meaning as aged? Is it dry, large, happy, or old? Yes, old is the correct answer. For spatial skills, this task addressed the ability to imagine and visualize objects in 2 dimensions. Participants were shown an abstract figure and had to decide which of these figures corresponded to this figure in 2-dimensional space. And where are the solutions? They are gone here. But let me tell you, C, E, and F are right. For the numerical task, and this one is interesting, I find, this task actually involved mental arithmetic. So participants were required to quickly determine whether the given sum of, so this is the sum of 3 2-digit numbers was correct or incorrect. So they had to sum up these 2-digit numbers and tell us whether this is correct or incorrect. So this one is correct and this one is incorrect, and they had 5 minutes to solve 70 problems. So here are the results. Roman Gonzalez and colleagues found significant associations between verbal skills, spatial skills, and reasoning with CT, but interestingly, numerical skills were not associated with CTT performance at all. They also performed a linear regression analysis to identify which of the 4 predictors could explain unique variance in CT. So unique variance could be explained by spatial skills and reasoning, but not by verbal or numerical skills. So in our current research, we're aiming to replicate the results of the contribution of mental arithmetic, and also extending this research by investigating the contribution of other theoretically relevant numerical and spatial constructs. Because we only have a very limited amount of time in this talk, I won't talk about the spatial constructs we also looked at, but rather focus on the numerical aspects. So here you can see the constructs investigated by Roman Gonzalez, and we decided just to not look at verbal skills for this research, but rather in another project. So what's interesting is that we actually not only looked at mental arithmetic, but extended previous research by also looking at higher order mathematical skills, such as arithmetic problem solving, going into the direction of algebra. And also for reasoning, we decided not to have just one reasoning measure, but also split it up into numerical and spatial reasoning, because these might have very different impacts. And to replicate the study, we want to have at least the same amount of participants as the original study, but if at all possible, many more, because the more participants, really the better, because we have really a complex model with many variables. Yeah, for numerical reasoning, so you can see a very similar task to the one employed by Roman Gonzalez, except that we are looking at sequences of numbers and not of letters. So you are asked to find which number completes this sequence. For spatial skills, we also have a classic visualization task. So the chair just entered my office and told me to hurry up. Yeah. And for mental arithmetic, we also had a task that involved solving calculations within a given time limit. Arithmetic problem solving involved having participants to identify the correct operators to given equations. So it's something more advanced than mental arithmetic to some extent. Today I'm going to show you preliminary results from 71 students. Many more will take part in the upcoming weeks. And just as a reminder of the original study, Roman Gonzalez and colleagues found relations between verbal spatial skills and reasoning, but not numerical skills. We could replicate the results on spatial skills and reasoning. It's highly similar what we found, but in our task, we could find a significant and not so low correlation between mental arithmetic and CT test performance. When entering all predictors into a regression analysis, the original study only found significant contributions of spatial skills and reasoning, but we could also show that numerical skills actually play a unique role. So mental arithmetic plays a unique role for CT performance over and above spatial skills and reasoning. Why do we find other results than Roman Gonzalez et al? Maybe it's because we are looking at a different population of students in a different country. Maybe our tasks are slightly differing. So Roman Gonzalez and colleagues only had addition problems, whereas we had other mathematical operations in our mental arithmetic task. But I'd say the tasks are slightly comparable or largely comparable. So I'm not quite sure why we found such a huge association, whereas the original study did not. So just as a last input, we found also a significant association between these higher order arithmetic problem solving skills and CT. Pupils who were better at arithmetic problem solving also performed better in the CT test. So we could replicate that reasoning and spatial skills are fundamentally important for CT, but in contrast to the original study, both mental arithmetic and arithmetic problem solving also seem to be linked to CT. So I'd say, based on this evidence, which is preliminary, that school-related mathematical skills should not be underestimated when aiming to promote CT for all students. And as an outlook, I'm looking forward to having much more data to be able to investigate the unique contributions of also other important variables. And here I'd like to thank all students, teachers, and schools supporting our research. And I'm looking forward to your questions.
Thank you very much, Sabrina. Any questions? Or was everything so clear? I would have a question, and actually it's related. I mean, it's very similar to Eva's question from the previous session. So why exactly do we expect an association between numerical skills and computational thinking?
That's really the main question we need to ask ourselves before investigating anything, right? Is there a theoretically grounded relation we would expect? And here I argue that higher order math skills, such as algebra, are inherently linked to the algorithmic thinking component of CT. Algebra is the first or for most children, probably the first instance where they are familiarized with this kind of algorithmic thinking, developing and applying solutions to problems that are, reusable solutions, making use of equations.
Okay.
But I myself, I was quite intrigued to also find this association between mental arithmetic and CT. This I can't explain to myself really based on theory.
Okay, thank you. We've got another question from Manuel Ninos.
Hello, can you hear me?
Yes.
Yeah, hi Sabrina, thank you so much for your talk. Really interesting. I think we all as a community, I think, need to come together, join, and maybe write a joint paper on the ideas that we have about the cognitive correlates of CT. What I would have been interested in hearing a little bit more, so how did the CTT work for you or for your age group? So what was the internal consistency maybe, and also have you looked at the potential gender differences, as Roman Gonzalez did find some gender differences as far as I understood, remember?
Mm-hmm. Yeah, so we decided to use the age group the original CT was specifically designed for, so grades 7 and 8. So the students did not have any difficulties with the items, and we allotted the exact same time limit of 45 minutes to the students. What I noticed based on our preliminary data set is that all students in Austria seem to be able to solve more problems than the original Spanish sample. So it would be interesting to see whether this trend persists and what are the causes for this. But we also asked our participants whether they already had some programming experience, and in our sample, 50% of students roughly did have some experience with robotics or Scratch or whatever. And so it would be interesting to see whether these differences may be also caused by prior programming experience or can be attributed to this. Yeah, and internal consistency, of course, this is something we need to report when actually submitting our final version of the registered report.
Thank you. We have time for one more question. Eva, please go ahead.
Thank you, Sabrina, for this talk. It's nice to get an overview in between before we get the manuscript back in December. I also had a question about the age range. So your age range is narrower than in the original manuscript, and I'm just looking at the moment at the different scatter plots they have presented. And you already mentioned in response to the previous question that your sample seem to be doing better on the computational thinking test. Mm-hmm. And I was wondering if the fact that you did find more significant correlations could have something to do with how the scores were distributed. Did you compare like your scatter plots, like how they, like the clouds, how they looked like with what they did in their study, and could there be like some indications what could cause the fact that you did find significant correlations?
Yeah, first to the original study, I'm not sure whether Roman Gonzalez and colleagues really stated it clearly, but as far as I read it, they based their analysis on the cognitive correlates of CT also on students in grades 7 and 8. Mm-hmm. So that's what I understood, and therefore we also looked at that age group. And the scatter plots in the original paper looked quite linear in terms of the relations, and all relations we find are also linear. And if all students perform higher, then it may mean that there is less variance in our group compared to the Spanish group. That's what I would expect. And then if there's less variance, I would even expect relations to be smaller.
Yeah.
Yeah. So that's a complete mystery to me at the moment. And I'm really looking forward to more data. Yeah, but what we also found is very similar relations in terms of spatial skills and reasoning. So we don't find generally higher relations, but only in the instance of mental arithmetic.
Thank you.